Hi everyone. What does the cubing function have that the squaring function doesn't? The cubing function is 1 to 1. So for example, consider the graph of y equals x cubed. Let's say I have a point on this graph and you care. And let's say I tell you that my point has x coordinate 2. You know that the y coordinate has to be the cube of 2, or 8, because we have a function. If I give you x equals 2, you know y equals 8. But wait a minute. Let's start the beginning. Let's say I tell you that my point has y coordinate 8. You know that the x coordinate has to be 2. If I tell you that the y coordinate is 8, you know that the x coordinate has to be 2, because this cubing function is a one-to-one function. The squaring function does not have that luxury. What was the problem with the squaring function? If you graph y equals x squared, the problem is that the graph, this parabola, will fail the horizontal line test, the HLT. Because, for example, the point 3, 9 lies on the graph, and the point -3, 9 lies on the graph. And the line y equals 9 will pass through both points, that horizontal line. So what this means is that we have two competing values for x here. The square of -3 is 9, but the square of 3 is also 9. We have Jennifer and Angelina competing for Brad. We have two numbers here, two different x coordinates whose square gives us the same y coordinate, 9. And that's reflected in the fact that the graph here fails the HLT. The point -3, 9 lies on the graph. Also the point 3, 9 lies on the graph. Here's a graph of y equals x squared. Let's say I have a point on this graph and you care. Now here's the problem. If I tell you that my point has y coordinate 9, unlike for the cubing graph, you're not sure what the x coordinate is, because I could be talking about the point 3, 9, or I could be talking about the point -3, 9. You don't know which point I have. We don't have a clean loop-to-loop here. If I tell you my y coordinate's 9, you don't know where to go back. This function is not invertible. If I tell you the y coordinate of my point is 9, you don't know what the x coordinate is. Basically, 9 has two square roots, +3 and -3. Who does Brad go back to? It's not a clean loop-to-loop. The way we had for the cubing and cube root functions. We had a clean loop-to-loop. There was no competition. Here, we have competition. Brad could go back to Jennifer or Angelina. So if we try to invert this function, we cannot get an inverse function, because an inverse function cannot do something like this, because no function will allow one input to yield two or more different outputs. So that's the problem. As it stands, the squaring function on the reals does not have an inverse function. You cannot reverse these arrows so that we get an inverse function. Well, question, how can we get an invertible version of this? And then how can we get the square root function? Now we're going to do this in trig as well. We're going to restrict the domain. It's true that this parabola, y equals x squared, fails the HLT. But do you see a piece of this parabola with the same range? It's as tall as the original graph here, but that will pass the HLT. Do you see a piece of this parabola that will pass not just the VLT, but the HLT? And it's as tall as the original graph. Don't just grab one point. No fair. Yes. By convention, we grab the right half of the parabola, the right half. You'll see that the range is the non-negative reals, just like before. It's as tall as the original graph in that sense. But this time the graph passes the HLT. So the squaring function, if it's restricted to this domain, the non-negative reals, is also the range, then it turns out that this function will be invertible. I call this new function g because technically, if you change the domain, you change the function, even though the rule, x squared, is still the same. But now we have an invertible one-to-one function. So 3, we know, goes to 9, and 9 has to go back to 3. It has to go back to Angelina. Negative 3 has nothing to do with anything. So now we have a nice loop-to-loop. All right. So a function is one-to-one if and only if the graph in the xy plane passes the HLT as well as the VLT. Remember, this restricted graph here on the restricted domain passes not just the VLT, but also the HLT. And again, because it's a one-to-one function now, it has an inverse. Namely, G inverse of x is going to be the square root of x. G inverse is the square root function. The square of 3 is 9. Now, the principal square root of 9 is 3, only positive 3. The inverse is a function. Next, how do we graph inverse functions?